Okay, today we're going to have a look at car safety features. And why they're important and how they work. So, if you are a passenger in a car which is about to crash into a wall, then what you're probably interested in is making sure that you don't get hurt. So we want the chances of being hurt to decrease, to go down. Okay? So what is it that actually hurts us? Well, what's going to hurt you and cause damage to you are forces. So we'd like the size of the forces that we feel on our bodies to go down as well. So how do we do that? Well, let's think if we've got any equations that might help us do this. So if we look through our formula sheet, we probably find we come across two equations that have got force in. One of them would be work done equals force times the distance over which the work has been done, or the force has been applied, sorry. And we find another one which would be F equals M times A. Now, interestingly, on your formula sheet, you wouldn't find that written like that. It would be written like this. Acceleration equals force divided by mass. So the first thing we're going to need to do is to try and make the force the subject of these two equations. So the way we do that is we'd think about putting them into triangles. So if we take the first one, well, I put the cross in the middle of the times sign, right in the middle of the triangle, and there's the times sign right up here. So it must be force and distance that go here, and then it must be work done that just goes in the remaining space. So if we do the same thing for acceleration equals force divided by mass. Now this time it's slightly different, but the line, the divide line, is through the middle of the triangle, so the F's on top of that, so that must go here, and it doesn't matter where the other two go. So now, using the triangles, cover up the thing you want to find out. So if we want to find out force, we cover that up. Force equals work done divided by distance. Okay? Just repair that slightly. Now, similarly, on this side, we cover up the thing we want to find out, which this time is the force, and we see that it's mass times acceleration. So we can write that down. Okay. Now, taking those two, let's do one at a time. So if we started with the force is work done divided by the distance. So if I want to make this as small as possible, these forces as small as possible, I've got two things I can do. Either, if I want this to be much smaller, I could make the work done much smaller, or the thing on the bottom of this fraction needs to get bigger. And if you're not sure what I mean by that, imagine this number getting bigger. So which of these is, if the number on the bottom gets bigger, then we can hopefully see that a half is greater than a third, which is greater than a quarter, which is greater than a fifth. So as this number gets bigger, this fraction, which equals the force, is actually getting smaller. Now, the work done is actually related to the kinetic energy of the car. So the more kinetic energy the car's got, the more work you're going to have to do. So one way of reducing the amount of kinetic energy the car's got is to basically slow down. But of course no one's really planning on crashing into a brick wall. This kind of just happens. So you're going to be doing the speed you're doing, so there's not really a lot you can do about that. Make sure your brakes are working, I suppose, try and brake before you hit the wall. But what we're really interested in is reducing this, making this distance as long as possible. And the way that happens is as the car crashes into the wall, the front end of the car crumples, and it's called a crumple zone. Now, this car is actually a bit, the passenger compartment is about there. Now, if we draw back in the original car was going to look something like that. Okay. So we can see that the car has got a little bit shorter. And it's this distance here that we need to be as large as possible. And because the larger we make the distance, the smaller this fraction is getting, and therefore the smaller the forces. Now, all car safety features, seat belts, they stretch, so you don't stop immediately, you stop over a bit of an increased distance. If you add that distance to the distance that the airbag stops you over, so your face hits the airbag and the airbag collapses and you continue moving forward, so you get a larger distance out of that as well. And if you add the distance of that to the distance of this to the distance of this, this distance keeps getting bigger and bigger and bigger, and the forces keep getting smaller and smaller and smaller. And your chances of being hurt also go down.